everyone. Thank you for coming. My name is Mark Conde. I am a senior technical engineer, or as they put it, the enterprise architect for security at Universal International for UPR. So a little about myself. As far as Universal IT, responsible for the ride show networks, corporate networks. I oversee the infrastructure for all theme parks as far as wireless security, ride and show networks. And I design the infrastructure as well for all new attractions. As far as my experience, I have over 20 years experience in IT, 14 years in cybersecurity, and in computer science, computer forensics. And I am a senior mentor of a number of ethical hacker groups. So usually I come to these and a lot of people see that, especially when you dress all in black. Oh, I skipped one. So one of the things I want to mention, yes, I'm an IT guy. I'm not a controls guy. Universal deemed it necessary to involve IT integrated into new ride systems, since they all are based on PLCs and SCADA systems. So past and present, legacy attractions for us, isolated networks, limited HMIs, panel views predominantly. The protocols that we use were standard device net, control net, data highway plus. We have very restrictive historians. The new attractions that we have are integrated with our corporate network, strangely enough, and they're tied together as we consider securely, and I'll show you later why we would make such a bold statement. Centralized management. We can manage multiple locations through one secure location. We standardize on use standard protocols, Profinet, Modbus TCP, and Ethernet IP. Has an open HMI, it's customizable, and one of the biggest things that we wanted to keep to is not vendor specific. So we try to stay away from vendor specific solutions, and it gives us a flexible historian. So as you can see, legacy attractions, big buttons. New attractions, and I won't say what that attraction is because I'm not authorized, but you can see what it is. It's an attraction with a certain wizard, all based off of a web-based HMI. So ride control, legacy ride control systems, big buttons, limited alerts. We had flashing lights, scroll displays. They located entirely within an attraction. And it was proven. It works, just like I'm sure many of your plants and facilities are the same way. New attractions, so we still have the buttons, but now we can control everything through the HMI. They're more complex to use, but it allows management, numerous components that we can add and remove on the fly. So greater alert details. We actually can provide real-time status of conditions. We have fault indicators that can give us a great deal more information, and we can do trend analysis, and which we do with a vast majority of our systems. So we have improved centralized management. Technicians are now carry tablets. It's all web-based. And they can walk to an attraction or to a situation and have the information readily available. And we can manage it outside the attraction should we deem it necessary. So key benefits, flexibility, it reduces lower cost of ownership for us, fewer components, less to fail for us, as we saw when we started centralizing. We minimized the number of panel views, which we felt was a potentially detrimental because it required somebody to run out to them. It gave us a competitive advantage to us because the design of the system could be utilized in other locations and other attractions, and it gave us greater security, which was a huge thing for us. So one of the things I like talking about is I wanted to make everybody understand the threats. So we decided, since our predominant role is to protect our guests, that it was important to assess and learn about the threats that are out there. So we started investigating, and we basically found out that, as everyone knows, it started with Stuxnet, but there's a whole slew out there of tools and kits that are available for free with YouTube videos to tell you how to do it, to how to manipulate PLCs. And in particular, we found that it wasn't vendor specific. So many of the appliances that we were utilizing are decade-old appliances, never designed to be on to support sophisticated network infrastructure. PLCs, we learned, well, control engineers know this, but IT guys didn't, that are designed to be accessed and managed easily. It's made so that you can do a lot quickly, efficiently, and it works. It's not secure, but it works. And the issue isn't about viruses, okay? The result, it can be of intentional and malicious and unintentional attacks. There can be manipulations, and it happens more often than not, is somebody who keys wrong something in a program, and it causes some major damage. We also tried to do it ourselves, and we found out that you can basically wreck a ride with just 4 lines of code. So that's all it took us. So security issues, so we did findings. So the typical findings were the exposure. So security issues with various PLC manufacturers, and not just their PLCs, but their software. We learned to manipulate systems utilizing nothing more than the demo software. We were able to circumvent things such as safety signatures while systems are running. You can do this. There are known ways of doing this, and they're very public. And the changes, the thing about it is we talked to various vendors, and the vendors all said, we're coming out with solutions to all this. The problem is that the solutions aren't here yet. And since the solutions aren't here yet, that leaves an area of vulnerability. Also, the reality is that to update firmware requires new fatting and satting of systems, and also requires downtime. So we also realized that there was critical and non-critical systems integrated with each other, which I'm sure happens in many organizations. In fact, the atypical backplane to a PLC provides you that freedom. You think a system is secure when actuality it's not. There was vendor access. This happens more often than not. Is usually unmonitored. Some people trust their vendors. Don't trust your vendor. I'll just let you know that. Physical access can be to control systems is usually readily available. A lot of times we leave the key on remote, and they leave the key on the remote because it's easy, right? You can program it on the fly. Well, the reality is that that's a problem. And there's physical limitations. Somebody can plug in on the fly. So there were locations, no cameras. There was unlocked cabinets. That's been addressed. So we also learned that it was safe to be online and networked, then be isolated, because we can then provide real-time monitoring, and that's what we wanted. We also realized one thing. We have an awesome perimeter, right? You have all these firewalls, because IT inherently understands the threats from outside. When it comes to industrial network and control networks, that is not really the case. So for us, it's safer to be, the threats aren't coming from the outside, the threats coming from the inside, okay? Infection by virus and worms are more likely in non-critical systems than critical systems. Why is that? Because for us, you determine that non-critical systems are usually the ones people don't pay attention to. And they do things on the fly, and they think, oh, it's just something for lights, or it's something for something simple, a door controls the system. A lot of the times they're interconnected. Sometimes it results in infections in critical systems because of the open connectivity between them. So we looked into how serious this was. So as I'm sure you guys have gone, and gals have gone to some of the summits of our security here and the Department of Homeland Security, we found that nation states have established a number, have felt that this is a serious enough issue to establish their own departments. So this is just 3, and I did this presentation in Singapore, but in Japan has their own. Singapore has theirs as well. Every major state in Europe has one. So keep that in mind, and it's very important that you understand this. And also work with these agencies, because they actually provide you a lot of information. This is something else we found out because we contacted the DHS. There's a YouTube video that's declassified at this point that shows and during a raid in Afghanistan, they found a number of Al-Qaeda laptops that all contain information to manipulate SCADA systems. In fact, they found maps of the power systems and petroleums and oil companies and gas companies in the United States and South America. They were all there. About 4 years ago, there was a hack known as Night Dragon. This hack wasn't detected for 3 years. And it was focused on energy and chemical companies. The amount of information they believe that they got, at this point, the DHS believes that there is a map of the entire United States power grid. So it's out there. 500,000 bots were used. They detected about 20%, 25%. So the challenges for us, and challenges I believe for you as well, they're implementing monitoring to legacy system without requiring retesting. So that's a big challenge, right? So you have a lot of systems that you can't really FAT or SAT test one more time. The other thing was, how do you address future-proofing legacy systems that lack the ability to obtain new functionality? So if you can't obtain the new functionality, then what do you do? And then we've tried to just sort out, can we monitor different vendor technologies with the same system? We developed one. And it's kind of funny to say a theme park developed one, but we did. But to answer a lot of these questions were, if you can't protect the system, then protect where it's around. You can build the walls of defense around it. And that's what you have to do. And it's a multi-layer approach, and I'll show you some of what we did. So there's a difference between prevention and detection, right? So detection, we monitor, we see something valued, that's detection. Prevention is, we can do something about it, right? Well, the reality is that we can we can prevent, you can detect more than you can prevent, okay? So this is some of our systems. So we put kind of criteria. We said, okay, so how do we future-proof our systems? So the first one was identify and categorize deficiencies. Network devices and user security had to be determined. We had to define a disaster recovery and business continuity, two very different things. Okay, a lot of firms do not take that into consideration. We planned scalability and made modular designs. So typically an attraction lasts about 10 to 20 years, and attractions usually don't change within that time frame. So we realized that going forward, scalability was a huge thing. So we had to add functionality. Features not currently being used may be required later, right? Attractions may not change, but they are rethemed. If you go now to see the attraction Despicable Me at Universal, that attraction was Jimmy Neutron, and before that it was Hanna-Barbera. So things change. The Mummy was King Kong. To respond to John's question about can we beat his vehicle speed, we have a coaster that goes from 0 to 60 in under 2 seconds. So if your Corvette can do that, then I want to ride it. So we built modular designs. We just chose components for everything new. Choose a component and a design structure that it allows technology changes. And this is in response to the change of systems going into the future. You have to build it modular. You cannot build this static. Don't think that this is the best that you can get right now. Think the best you can get in the years to come, okay? And the solution should adapt to new requirements. So that's what we kind of came up with. So user and connectivity and mobility. So what we started doing, we decided Ethernet was important for us. We started integrating key systems together through Ethernet. We had surveillance system projectors, remote I/O, drives. We decided the best thing to do is tie them into Ethernet and we standardize on that. So we started building also a building-wide secured system. So wireless. So we decided that we had needed multiple levels of security in the wireless, and we added dual-factor authentication. We added the levels of encryption, and we chose devices that we can do such things. So the scalability of the technology selected, the infrastructure design, as I said, was adapt to change. Technology should be modular. Scalability should never sacrifice security or safety. You can't pick something because it's cool. And I really must emphasize that. Redundancy. Build anything in the future or in the present or anything you're going to put in the perimeter around an existing legacy system with the resiliency for component failure. Plan your networks well. HMI and the HMI should never go down, okay? I guess I got to go quicker. So we also started doing analytics, troubleshooting. So as issues were identified, as you can see bound down there, that's one of our tablets. Technicians could respond quite faster. Technicians have the HMI with them at all times, and that's a key thing. So downtime avoidance and predictive maintenance was another thing. We started doing trend analysis. We started doing predictive analysis of failures of components, delamination of wheels and such. We started building trends to that. So this also works with drives, motors, valves, and such, because we use lots of those components. So security enhancements for life safety. We adopted OPC UA, and the reason for that is because the new OPC UA is not Microsoft dependent. We reduced that, which reduces for us the risk of infections. We also use certificate-based security. We integrate with existing IT, proven IT solutions. They're provision-based, so we can actually adapt it to our LDAP or Active Directory, and design for high availability and redundancy, which I must bring up a number of times. Design everything with redundancy in mind. And it gave us greater support for historical events and trend analysis, which we are big on. And data context, it gave us intelligent data handling as far as providing additional information that we normally didn't have before. Okay. So this is not our network, I can say that much, but this is a recommendation of what you do. I won't say if it's ours or not, but I will say this is a sound way of doing it. And the reason for it is you have firewall corporate network here, you have another firewall here. Within this space is VPN into this location. There are authentication servers sitting on the perimeter. There's an intrusion detection system, antivirus system. So prior to any entry, systems have to be validated. Now, we don't allow individuals to manipulate systems directly. So we provide them a virtual desktop that exists within the space of the attraction. So we use a secure proxy. You basically get in here. Everything is contained within here. There is no vulnerabilities to viruses. The reason is because you can't write from here to here. All you can use is the application that exists here. This also provides digital firewalls to isolate by cells, build cells, protect your critical system. This is key and this is important. This design works. Is it the best design? It's the best we can come up with so far. So far, we have not been able to defeat it. So what are the requirements for us? Reliability, secure, protected, isolated, monitored, and most of all, we must protect our guests. That's what we do. We have to protect you because the last thing we want is something bad happening. So what we did, how did we address it? And these are just recommendations. We partnered with the Department of Homeland Security. We did virtual access. We put in firewalls, but firewalls are not enough. It is not enough to put a firewall in line. Firewalls will not prevent authorized communication from getting from point A to point B. If a bit is said to be on when it's off, a firewall won't stop that. Okay? And if that means that something crashes into something else, it will. So enable VPN access. Critical systems should be firewall between each other so that communication is only authorized between source and destinations that you allow, and map this out. Intrusion detection systems should be put on the perimeter so you know exactly who's in there or is getting in there. Maintain your virus and patch management. Ensure that there's ongoing audits. Audit often and audit autonomous to people. Don't trust people to do the audits. Have systems to do the audits. We realize that too. And develop fluid documentation for business continuity and disaster recovery. They're two very different things, and I cannot keep emphasizing how important that is. Business continuity for us is is there a component that's been impacted, and what's the recovery for that component? Disaster recovery for us is if the park is down. Okay. So just to continue, we recommend enabling port security. Network components should always be redundant. Wireless communication, you should utilize MAC filtering at the very least. And your encryption level should be at the very least WPA2 enterprise. And wireless networks should be separated by channels and protocols. So if you're using some specific protocols, I recommend you using it on different channels. Okay. Certificate-based VPNs, authentication, isolate LDAP or a Active Directory within the space. Use dual-factor authentication. Don't trust one source. One source can be hacked. 2 is difficult. 3 is even better. And revision control. All changes should be well documented. This is key and important to any sort of facilities. I'm sure you have processes to handle that. The other thing for us for safety networks, anything that has to pertain to potential risks to humans, are to be isolated and secure. I/O is on its own dedicated VLANs. If you're using Cisco gears or such, you can isolate campuses using VRFs, which is another added layer. Okay. Audits of environments need to be done regularly. Once again, for especially security, and environments should be monitored continuously. The device you see over here is our real-time stop. We do e-stops now through secure wireless, so we can actually stop an attraction or any of our operators or technicians in the attractions. If you ever go to any of our parks, you'll see them having these hand packs. Goes to secure wireless, certificate-based, and it's a trusted source, so nobody can manipulate those systems. So you can't just stop the ride. So reliability is key. Good network design is priority. Network components should always, as I say, and I keep reiterating, redundancy. Critical components should have at least dual connectivity back to a switch. You should always have this. And beware of competing networks. You can deauthorize the most secure network because the management packet within any wireless, including your house, is unencrypted. Okay? So all I have to do if I wanted to do something bad, which I don't, I'm an ethical hacker. I'm the white hat. I'm not wearing black, but I'm the white hat. But if I wasn't, I can deauthorize your packet and authorize mine. So guess who controls your wireless? And it would only take me less than, 2 minutes. Minimize single points of failure. This includes personnel. Don't have one person who knows everything. Have a lot of people. It's important. If you lose if you lose somebody who's critical to your infrastructure, that's as bad as losing your main hard drive or main data or your historian. This is important. Okay. So this sounds great, right? So how do you get this going? So we realized that it was important to build this. So this was the little drawing I did for our CIO and CEO, and I basically said, you need somebody right here. Okay? That became me and my group. So an IT that understands automation, okay? Automation staff that understands IT, concepts of IT. You need to have some sort of understanding. It's important. You can't talk apples to oranges because they don't get it. It also has to be fully integrated with your operation. Operation needs to understand what is going on and what is happening in their systems and how to manipulate the systems, okay? This requires group commitment, and I can't. The first thing I usually say in these conferences is, please hold throwing stuff at me because I'm an IT guy till the end, because it's true. IT and control guys usually don't get along. You have to change that. It's imperative to change that. That philosophy has to change. And executive sponsoring is mandatory. You can't do this unless the bigwigs are all on board. So lastly, just 10 recommendations. Build policies. Get policies in place. Figure out how things interconnect. Develop standards. Work with different organizations. Okay? Between the organizations, build the standards. Plan your security architecture. Don't just implement something like a firewall in line because you think it's cool to be safe. Build your access management. How do you get there? What do you do? What happens when it gets there? Dedicated resources. This is the team. You have to have a dedicated resources, and it's not just one person. Change management, ongoing. Physical security, plan it. It's as crucial as your electronic security, okay? You have to be constantly aware, and this is something that has to be promoted upon not just to the very low person on the totem pole to the very highest. They have to be constantly aware. Audits and technical assessments needs to be done, and cooperation between IT and industrial engineering is mandatory. You can't do this alone. You cannot do IT by being a controls guy thinking you can do, and vice versa. So you have to work together. There is no ifs, ands, or buts. So thank you for attending. If you have any questions or you need any help or guidance in this stuff, I'm more than happy to help. You can reach me on either one of those. If you ever need somebody to talk to an executive board and scare the bejesus out of them, my wife calls me the boogeyman. So there you go. Thank you.